Good morning, this is Kavipriya, Assistant Professor, EC Department, SNS College of Technology. I am going to discuss about the topic Thevenin's theorem from the subject Circuit Analysis and Devices. So first we can see what is the statement for the Thevenin's theorem. Thevenin's theorem is one of the networks theorem which is used to simplify the complex network. So in case of Thevenin's theorem, when we apply a Thevenin's theorem to any linear two-terminal bilateral active network which consists of number of sources and which consists of number of circuit elements can be replaced by a single voltage source VTH, which is called as a Thevenin's voltage, or it can be, we can even call it as an VOC, open circuit voltage, in series with the Thevenin's resistance RTH. RTH is an effective resistance looking back from the terminals. So this is a Thevenin's equivalent circuit. Any linear network which has several sources and resistance can be converted to a more simplest network which consists of an voltage source in series with the resistance. So this voltage source is a VTH or VOC, and equivalent resistance is a RTH. VTH is a Thevenin's voltage and RTH is a Thevenin's resistance. VTH or VOC. VOC is a open circuit voltage. So next we're going to discuss about the steps involved in solving a problem when we apply a Thevenin's theorem to the particular circuit. First thing is that you have to consider a circuit diagram by opening the terminals with respect to the Thevenin's equivalent circuit to be found. We have to first find the open circuit voltage or Thevenin's voltage VTH across the terminals of the open circuit. Next, we have to find the Thevenin's resistance RTH across the open terminals of the circuit by eliminating the independent sources that is present in the circuit. We can short circuit the voltage source or open circuit the current source, whichever which is present in the circuit. And next, we have to draw the Thevenin's equivalent circuit by connecting the Thevenin's voltage VTH or VOC in series with the Thevenin's resistance RTH. And next thing is that we have to find what is the current that flows through this load, and we have to find what is the voltage that is available across a load. This is the process involved in the Thevenin's theorem. Now we are going to apply the steps what we have seen above in the given circuit. So in this circuit we have this voltage source 30 volt and we have the resistance 12 ohms, 6 ohms, 4 ohms and 2 ohms, and 2 ohm is a load resistor. First we have to remove the load resistor 2 ohms and we have to find what is the voltage that is available across a terminal AB. So to find this VAB, we can apply this voltage division rule, or we can apply the Kirchhoff voltage law to the closed path 30 volt, 12 ohm and 6 ohm. That particular closed path, we can apply the Kirchhoff voltage law and we can find out what is the current that flows in the particular closed path. And we have to find this VAB. So VAB is equal to the voltage that is available across a 6 ohm resistor. Both are equal. So we already know what is the current that flows in the particular loop. And next we have to find what is the voltage that is available across the 6 ohm resistor. So voltage across a 6 ohm resistor is equal to current into the particular resistor value, I into 6. So we can follow either voltage division method or we can follow the Kirchhoff's voltage law. Either will be giving, both the method will be giving the same answer. So the voltage available across this VAB is equal to 10 volt. So after finding this VTH, next is that we have to find the RTH, which is a Thevenin's resistance. For this we have to remove the load resistor and we have to short circuit the voltage source or open circuit the current source. In our diagram, we have only the circuit diagram, we have only the voltage source. So we can short circuit this voltage source. After that we have to find the equivalent resistance. Here 12 ohm is in parallel with the 6 ohm resistor. So to that combination 4 ohm is in series. So when we apply this resistance in series and resistance in parallel combination to the circuit, we'll be getting this RTH value as a 8 ohms. So we have found this VTH and also we have found this 8 ohms. Next step is that we have to draw the Thevenin's equivalent circuit. In Thevenin's equivalent circuit, first thing is you have to put is a voltage source. VTH. It is nothing but 10 volt, and we have to connect a RTH resistance in series with the voltage source. So the RTH value what we have got is a 8 ohm, and through the diagram we know what is the value of this load resistor, which is nothing but 2 ohms. So VTH, RTH and load resistor. Next step is that we have to find what is the current that is available across flow through this 2 ohm resistor. For that IL is equal to, which is nothing but VTH divided by RTH plus RL. So by applying that formula we can find what is the current that flows across a 2 ohms. So after finding the current, the voltage available across a 2 ohm is nothing but current into the value of particular resistor, which is nothing but 2 ohms. So the voltage we have got the value as 2 volt, and the current we have got the current value. From the current value we can calculate what is the voltage that is available across a 2 ohms. So nothing but current into the corresponding resistor, which is nothing but 2 ohms. So we'll be getting the final voltage available across the 2 ohm resistor as 2 volt. Here the voltage division method has been followed. Either we can first we can apply the formula and we can calculate the IL. After that we can find the voltage. Either of the method can be applied. And next example for this Thevenin's theorem is that we have to apply the Thevenin's theorem to the circuit shown in the figure. And here we are also will be having a voltage source, and we have the load resistor value is mentioned as a 5 kilo ohm. So first thing is that we have to calculate the VTH. For calculating the VTH we have to remove the load resistor, and we have to find what is the, for calculating this VTH, we have to remove the load resistor and we have to find what is the voltage. And for calculating the RTH, we have to remove the load resistor and we have to short circuit the voltage source. Okay, here the VTH value is 12 volt and RTH value is 11 kilo ohm. So after that we have to draw the Thevenin's equivalent circuit. For the Thevenin's equivalent circuit consists of the VTH in series with the RTH and will be having the load resistor. So load resistor is mentioned in the circuit diagram that is mentioned in the question itself. And after that we have to find what is the current that flows to the RL, which is nothing but VTH divided by RTH plus RL. So after calculating the current, and we have to find out what is the voltage that is available across the load resistor, which is nothing but what is a load current into the corresponding resistor, which is nothing but 0.75 into 5 kilo ohm, 0.75 milliampere into 5 kilo ohms. So the voltage that is available across the load resistor is nothing but 3.75. So first thing is that we have to calculate the VTH. Second step we have to calculate the RTH. For calculating the VTH we have to remove the load resistor. And for calculating the RTH, we have to remove the load resistor and we have to short circuit the voltage source or open circuit the current source. So after calculating this VTH and RTH, we have to draw the Thevenin's equivalent circuit, which consists of the VTH, RTH and RL. Next step is that what is the current we have flows through the load resistor we have to find. After finding the current that flows through the load resistor, we can calculate what is the voltage that is available across a load resistor. V is equal to IR formula. We can apply Ohm's law, we can apply it, and we can find what is the voltage that is available across a load resistor. So this is the procedure for applying the Thevenin's theorem, and this is the steps that is involved in the Thevenin's theorem. Next we are going to see about what are all the applications of the Thevenin's theorem. It is mainly used in the analysis of the power systems, and it is used in source modeling and resistance measurement using the Wheatstone bridge. And what are all the limitations of the Thevenin's theorem? Thevenin's theorem is used only in the analysis of the linear circuits. Linear circuit is one whenever there is a change in the input, the corresponding change has to be produced in the output. Such circuits are called as a linear circuit. So this Thevenin's theorem cannot be applied for the non-linear circuits. And power dissipation of Thevenin's circuit is not identical to the power dissipation of the real systems. And next is the assessment questions. So what is a Thevenin's theorem? Thevenin's theorem is it's something which it is used to simplify any circuits. So which any linear circuits. So even the circuit can be a more complex circuit. By after applying the Thevenin's theorem, we'll be getting a more simpler circuit which consists of the Thevenin's voltage in series with the Thevenin's resistance, and will be having the load resistance connected across it. What is a Thevenin's voltage? Thevenin's voltage is the voltage that appears across the two terminals is called as a Thevenin's voltage. And what is where the Thevenin's theorem is used? So Thevenin's theorem is mainly used in the analysis of the power systems. So that's all about the Thevenin's theorem. Thank you.